All right, so today we are sketching polynomials. We've graphed a bunch of stuff. This is sketching, and so I will explain to you exactly why there has to be a difference in just a little bit. But instead of starting with the list of things we need to make this happen, we are going to start down here at the bottom. And this should look very familiar, because not only have we talked about end behavior multiple times, this was on the two sets of notes that you had to do right before this, almost the identical thing. So ask yourself, is this important? Yeah, I think that means this is pretty important. So one of the things that we have to think about when we are sketching is what does the end behavior look like? We'll worry about middle behavior later. But if it has an even degree, remember your even degree has a parabola-like shape, and your odd degree has a cubic-like shape. Okay? So if it's even, the ends are the same. It's either up, up, or down, down. If it's odd, then the ends are opposite, down, up, or up, down. Okay? So if I have a positive leading coefficient and an even degree, then my end behavior is up, up. I am not drawing a parabola because I'm not saying it looks like a parabola, but I do know that my end behavior has to be up, up. So that means that as x approaches infinity, f of x approaches infinity. And as x approaches negative infinity, f of x approaches infinity. If I have a negative leading coefficient and an even degree, then it's going to be down, down. Only worried about the ends, not the middle right now. So here, as x approaches infinity, f of x approaches negative infinity. And as x approaches negative infinity, f of x approaches negative infinity. For the odd degree, okay, positive leading coefficient, odd degree. It's going to have the same end behavior as a cubic, but we're just talking ends, not the middle here. So it would look like this. So it's down, up, meaning that as x approaches infinity, f of x approaches infinity. As x approaches negative infinity, f of x approaches negative infinity. If I have a negative leading coefficient and an odd degree, that's going to be that reflection in the x-axis. So they're opposite because it's odd, and this is up, down. Okay, and sorry, down. And so as x approaches infinity, f of x approaches negative infinity, and as x approaches negative infinity, f of x approaches infinity. Okay, so this time around, we're not going to be writing this out so much as drawing our little arrows, because that's going to be a huge part of what's going to help us sketch our polynomials. So I'm going to talk you through the 7 things that we have to focus on to make that happen before we actually do one. Most of it you should at least know what it means, and I'll show you how we're going to use it. So we have to find the x-intercepts or the zeros and pay attention to how it's asked, because this would just mean I'm putting the x values. This means I'm putting the ordered pair. I also have to find the Y-intercept, and that's just a constant when it's in general form. But right now we're going to focus on ones that are everything in factored form, so we're not going to be able to see it that way. Then we're going to notice if the polynomial has an even or odd degree, and we look at the highest degree, right? Not always the first, but the highest. And then notice the sign of the leading coefficient. And then we're going to determine the end behavior of the polynomial. So these 3 things kind of all go together here and would tell me something like this. If the leading coefficient is positive, then it's either going to be up, up, or down, up, right? And if the leading coefficient is negative, it's either going to be down, down, or up, down. Okay. So then we also have to notice if there are any factors after it's factored, factors with a degree higher than 1. Okay. What that means is after it's factored, if I have something like x plus 2 squared, the factor is x plus 2, and the degree is higher than 1. Or I could have, x minus 5 to the third, or whatever, after we factor it. That's what it means by a degree higher than 1. And then here's what we get from that. If I have an even power of a factor if it's higher than 1, so even power of a factor gives a relative min or max on the x-axis. So another way we look at that is this. That means whatever's going on with the graph's going to come down. I have a relative max or min on the x-axis like this, and then it keeps on going and doing whatever it's doing. That's just a little piece of the graph. So we say that it bounces. It can bounce from the top or it can bounce from underneath, but this is a bounce. That's not the official term there. What that really means, if I have the even power, that means that this is going to be tangent to the x-axis. Okay? We'll talk a little bit more about tangency in just a minute. So then if I have an odd power greater than 1, so like this right here, there's my odd power greater than 1, it locates a point of inflection on the x-axis. So that means that it would look like this, and then that's where my little point of inflection would be. So this is our bounce. We call this a wiggle. Obviously not the exact terms. This is a point of inflection, and this is tangency, but to help you think about what you're actually drawing, you have bounces and wiggles, okay? Then we draw the continuous curve, because remember, polynomials are always continuous curves, observing proper behavior at each 0, y-intercept, and in behavior, okay? So let's see how we're going to put all this together. So the first step was to find the zeros, okay? And this is already factored for me. So finding the zeros is going to be pretty easy, right? So basically I use my zero power rule, and my zero product rule. And so that means that if I set each one of these equal to 0, this would give me that x equals -1. So I get -1, 0, because this says X-intercepts. Then this one would give me 3, 0. Then this one would give me -4, 0. Step 2, and you don't necessarily have to do them in the order of the steps on the other page, but you can just fill in the blanks, but we'll go through this. We're going to find the y-intercept, okay? So it's the constant when it's in general form, but these aren't in general form. So that means to find my y-intercept, I'm going to get y equals, and I substitute 0 in for x for each one of these. So I'm going to have to multiply 1 times a -3 times 4. So when I do that, I get -12, so this is 0, -12. Okay. So then it says to notice if it's an even or odd degree. Well, I actually don't have any terms to look at for that, and I'm not going to multiply this all back together, but if I did multiply it back together, what would my highest exponent be? Well, I have 3 x's, so the most I'm going to get when I multiply all that back together is 3. Okay? So the degree is 3, which makes this a cubic. My in behavior, all right? Well, this is an odd degree. Well, actually, the sign. Sorry, I was trying to go by the order on the front. The sign of the leading coefficient. Well, there's no negative out here, so it's positive. That's going to help these two things are going to help me with the in behavior. So since it's odd, it's opposite. The in behavior is opposite. Since it's positive, my in behavior looks like this. Then I notice if there are any factors with a degree higher than 1. There aren't. These all just there's just one of each of them. Now I'm going to draw my continuous curve. Now when I draw my curve, well, I don't want to scroll too much here. When I draw my curve, I need to do some stuff to these blank axes. Now I'm not going to put every single little hash mark ever, but I'm going to do this according to just whatever I have for my zeros. I got to get my zeros on there. So since I've got this -4 here, I will go out, I'll make it like maybe 5. So 1, 2, 3, 4, 5. And then 1, 2, 3, 4, 5. So you don't have to get out a ruler or anything, just, try and space them as evenly as you can. I'm going to plot my x-intercepts. So I have one at -1, 0. I have one at 3, 0. And I have one at -4, 0. Then I have my y-intercept is at -12. So on my y-intercept, I'm not going to worry about making hash marks at all because I'm always just going to have 1. So you can just put it anywhere. And this is at negative 12, and I have a point there. Okay. All right, so then I'm going to graph this thing in here. So I know what my end behavior is. It's down, up, right? So that means that if this is my first intercept, I start from down here, and I'm going to cross through the axis right here. I go up. I don't know how far I go up. This is why we're sketching and not graphing. In order for me to find a relative maximum algebraically, that requires calculus. Sure, I could punch buttons on a calculator, but that totally defeats the purpose of the concept here. So we're going to go up. We don't know how high, whatever. We're going to come back down, right? And then I'm going to have to go through this point, through my y-intercept, which is not necessarily a minimum. It could be the minimum, but maybe the minimum is farther. I have no idea. And then I'm going to go back up through this 0, right? And then I'll keep going, which means I have my up on this side. So my sketch would look something like this. I start down here, go up. I don't know how far. I'm going to go down through this 0. I'm going to go through that negative 12, and then I'm going to come back up here, and I keep on going to infinity. When you're done, you make sure that your end behavior, which is down, up, matches the end behavior right here. Okay? And then I want you to make a little note here that this is not necessarily a minimum. Okay? It could be. We don't know because we can't find that because we don't have the calculus behind us. So maybe this goes up really far and I didn't know that. Maybe this is a minimum, who knows? But that's the sketch of my polynomial. Okay? So let's do another one. And instead of going by the order on the front, I'm just going to walk you through the blanks here because it's really the same thing. It doesn't matter what order you do it in. So I need to find the degree. So I figure out how many factors I have. Now this has x minus 2 squared. And this is the proper way to write it, but I want you to think about the fact that this is the same thing as y equals x times x minus 2 times x minus 2 times x minus 6. Okay? So that's what's happening. And if I was going to multiply all this together, I would multiply x times x times x times x, right? Which means there are 4 of them. So the degree is 4. That makes this quartic. And then I want you to think about what that little 2 does. This is one of my factors, and I have a degree higher than 1. So that's going to be important in just a minute. My end behavior, so I look at the leading coefficient, it's going to be positive and it's even. So my end behavior is up, up. My x-intercepts, I find my zeros here. So this one gives me 0, so I'd have 0, 0. This would give me 2, so I have 2, 0. And it shows up twice, right? I have this, so I'm going to put a little asterisk here because this is the one that has that exponent higher than 1, so I'm put a little star there. And then I'll go ahead and find this one. That would be 6, so this is going to be 6, 0. Okay? So that little star there, I have a factor that has a degree higher than 1, and it's even. And so the even means that I have a bounce. So I'm going to have a bounce there at this 0. Then I'm going to find the y-intercept. So y is equal to, and then I substitute in zeros, so it's 0 times negative 2 squared times negative 6. So since it's 0 times all of that, it's clearly going to be 0. But let's just talk about what if it wasn't. What if this was 1 or something? You can't forget to square this. Okay, like here I just multiplied them all together, but I'd have to square this. So this would be a positive 4 times a negative 6 giving negative 24, but then it all just gives me 0 in the end anyway. So my y-intercept is 0, 0. Okay? So now I am going to figure out, so I have 6 as my largest x-intercept. So I'm going to mark off 6 here. So I've got 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. So we just do the best you can to get them sort of spaced evenly. Then I'm going to plot some points. So I'm going to plot the 0, 0. I'm going to plot 2, 0. And I'm going to plot 6, 0. Okay, so I've got my 3 X-intercepts plotted, and one of the X-intercepts happens to also be the Y-intercept, so I've got those points. That in behavior, that's important because it tells me where to start. Like the first time I'm going to cross through the axis is right here, and since my in behavior is up, up, I have to start up here. I'm going to come down through this one. I go up here, but here, this is the 2, 0 that has a little star on it. I'm not going to pass through it. I'm going to bounce off of it, come back down, and then go up and keep going. So it's going to look something like this. I'm going to go down here. I'm going to come up. I'm going to bounce off of that axis, go back down, I don't know how far, and go all the way up. So again, I don't know. I missed that one a little bit, but you get the idea. Ooh, make it a little bigger. I don't know how far I'm supposed to go down for these minimums. Okay, that's why this is a sketch. I've got tons of information here, just not these, but they may not even be important to me for what we're doing. So when you're done, your in behavior's up, up. We're good. We went through all of the zeros. I have my bounce here at 2 where it needed to be. Okay, so even though, yes, we call it a bounce, I'm calling it a bounce, this is technically tangent to the axis. Okay. It's a point of tangency because it just touches it, intersects at that one point. Okay. All right, so let's look at number 3. So I want you to pause this, and I want you to fill out everything you can here, and then come back and walk through it with me, make sure it makes sense, and do that before you graph it, or before you sketch it, just in case it's not all correct. Okay? So pause and then come back, because I'm not actually pausing. All right, so I'm going to look at this, look for my degree. So this is x to the third. So that's 3 x's right there, and then 4, 5. So the degree is 5, which makes it quintic. So it's an odd degree, which means the ends are opposite. This is negative, so that means that it's opposite of what a cubic would be. So it's going to look like this. That's my end behavior. All right, so my x-intercepts. Well, this is going to give me 3, 0. This is going to give me negative 4, 0. And this is going to give me negative 1, 0. But I have to pay attention to the fact that this was to the third power. So that means here, something's happening. So when you have an odd degreed factor, because remember, these are my factors. Okay, those are my factors. One of them has an odd degree on it. Then that makes it a wiggle, which is, again, not an exact term, but it's a wiggle, or really it's a point of inflection. So then we're going to do the y-intercept. So when I'm finding the y-intercept, I'm substituting in 0 for x, but everything else has still got to be there. So I've got this negative sign, and then I'm going to have negative 3 to the third power times 4 times 1. Okay? So I'm going to have negative 3 to the third power is going to give me a negative 27, and then that's going to become negative, so that means it's a positive 27, so that I now have 27 times 4. If I double 27, I get 54. I double that again, and I get 108. So this is at 0, 108. So make sure you agree with all of that. If you got to adjust anything, then pause and do that. Write questions out to the side if you have them for class. All right, and so I'm going to now put stuff on my x-axis. My largest or smallest one is 4, so I'm going to go 1, 2, 3, 4. I can make 5. 1, 2, 3, 4, 5. Then I'm also going to have to mark off, oh, that looks kind of bad. Make my own shadow on here so I can't see what I'm doing. Okay, let me start over, make them a little bit more even. 1, 2, 3, 4, 5, and then 1, 2, 3, 4, 5. Okay, and I also have to have a Y-intercept. Well, I definitely am not making 108 hash marks there, so I can just go up here and go, oh, there we go, this is 108. Good enough. Not necessarily to scale, right? Or even if it is to scale, the Y and the X don't have to be the same scale. Okay, so now I'm going to plot the points, and I've got 3, 0. I've got negative 4, 0. Got negative 1, 0. And then I've got 0, 108. Okay, so pause this. Try and sketch this in. Think about your end behavior. Think about what happens at the point of inflection. Or actually, well, yeah, just try it, because you can always just undo. So try to sketch it in, and then watch me do it. And if you need to go back and adjust, that's fine. Undo is Control Z, undo. It's like my best friend, right? And if you're doing this on paper, then just sketch it lightly with a pencil. That way, if you have to fix it, it's not going to be very difficult to erase. All right, so let's try this. My end behavior is up, down, right? So I'm going to have to start up here. I have a point of inflection at 3, so that's over here. So I'm going to start up here. I'm going to come down. I don't know how far, whatever. I'm going to go back up through here. I'm going to hit 108, not necessarily the maximum, but maybe. Then when I hit this point, I'm not going straight through and I'm not bouncing back up. I'm going to go through and I'm going to have a wiggle because it's a point of inflection. Okay? Now, the wiggles are tricky sometimes. I mean, for me as well. So sometimes when I know where it is, I go and kind of sketch one in, maybe lightly if I'm doing it with a pencil first, just so I can get the curve. Because when I'm sketching like this, I can't always get that little point of inflection. So you just think about it as a cubic. Well, and then this one, since it's going this way, it would be more like, a reflected cubic. So like something like that is going through there. So it would be something like this. Okay. So I'm going to start. So I kind of already have that. Let's see if I can attach to it. So I start up, and I'm going to go down, go up through here. I hit 108, and then I'm going to hit this, and I come down and I do my wiggle, and it keeps on going. And there you go. So I have up, down. I've taken into account all of my zeros and my Y-intercept, and I am good to go. And if you went, way farther down here, that's fine. If 108 was your maximum, that's fine. I mean, there's certain things where they're going to look different, but you're still doing them okay. Right? Okay, so why don't you try and fill out number 4? Okay, and then we'll pause, fill it out, and then come back. All right, so the degree. This is 3 x's and this is 2 more, so this is 5. The degree is 5, which means, again, it is quintic. In behavior, okay, so this is odd, and it has a positive leading coefficient, so it looks like this. X-intercepts, I'm going to have one at negative 3, 0, and then one at 3, 0. And here, they both have, I'll put like 2 stars on this one. For the negative 3, 0, this has an odd exponent, which means for one little star, we have the wiggle, which is also the POI. And what I'm writing down, this is exactly what I would do if I was sitting down doing it all by myself, okay? Because if you don't make note of that, you're not going to remember to do it when you sketch it. So it's not like I'm just doing this for y'all's benefit. All of this is the exact same thing I would be doing if I was working these problems. Which I am, obviously. But so then this one has an even, so that means that is my bounce, which means it's tangent. Okay. Then I need to find my Y-intercept. So this is going to give me Y equals 3 cubed times negative 3 squared. So 3 cubed is 27 times a negative 3 squared, which is 9. So I would do 9 times 20, which is 180, and then 9 times 7, which is 63, so that gives me 243. Oh, I can't write the number. 243. All right, so I will put my little hash marks in here. I'm just going from -3 to 3, so I can space these out a little bit. 1, 2, 3, 4. 1, 2, 3, 4. Okay, that's good. And then I have a positive 243. I'll just make that 243, and we're good to go. All right, so I plot -3, 0, and I plot 3, 0, and I plot the y-intercept. Okay. My end behavior, it's down, up, so I start down here. At the -3, 0, I have a wiggle. So I'm going to start here. I'm going to have a point of inflection coming up. I'm going to go through 243. When I hit this point, that's where I have the bounce and where it's tangent. So it's going to bounce back up, and then we'll be going up at the end like we want to. Okay? And so this graph would look probably a lot better and be maybe easier to do if 243 really was a lot farther up, but it doesn't matter. So since I know I'm coming this way, and this is a point of inflection, I'm going to draw it first because, again, it kind of would help me. So it's kind of, I got that cubic look like that. All right, so start down here. I go up. I'm going to go through 243. When I hit this one, I'm going to bounce and come back up like that. So I have my point of inflection right here, my bounce. I have my end behavior down, up, and that looks good. So let me see if I can get rid of that mark. Yeah. You do your assignment on Delta Math has you do this stuff. So it may not ask you to always put in all of these things or like type it in, but you have to know it to be able to do it. And it's going to give you a blank graph and it's going to tell you to sketch it in. So just like on these, it doesn't matter how far down you go on this because you don't have to know that. It's a sketch. But you are going to have to literally draw it. I worked through some. I used my mouse because I was using my big monitor. So it looked a little crazy, but I could hit the points just fine with my mouse. So if you don't have a touch screen, it is totally doable. But you could use your finger or a stylus to be able to get it in there. And it's really the exact same thing as this. And you have to have all of these pieces done. So I would, write them all out somewhere so that you can hit what you need to hit. Okay? And there you go.